Hello everyone, welcome to TEJOMAYA YouTube channel. So in this session we are going to discuss about a new concept, that is electric field due to linear charge distribution. So under the concept of continuous charge distribution, we have linear charge distribution, surface charge distribution and volume charge distribution. So in this chapter we mainly talk about linear charge and surface charge distributions. In that, this is the first one. So what is linear charge distribution? Let us learn about the basics. So if I consider a kind of charge, maybe positive or negative charge, is distributed along the line. Some n number of charges distributed, somewhat difficult to count, like this. We have already studied that electric field due to one charge, if I consider a part of it, so let us consider a small charge or point charge we call. So electric field due to point charge at any point is given by E is equal to 1 over 4 pi epsilon naught, this charge divided by r square. R is the distance, correct? No? So from this charge to this point, what is the distance? R. So electric field due to point charge at this particular point is given by 1 by 4 pi epsilon naught q by r. So sometimes for competitive exams you can write 1 by 4 pi epsilon naught as k q divided by r square, k q by r square. Now what is the electric field due to all these charges? So can you able to add the electric field due to all these charges? So find the electric field due to this one and this one, this one. For example, 1 crore charges are there. How will you find out? Very difficult, right? There comes the concept of linear charge density. So what is linear charge density? If I consider this is the wire, so I will consider the total length of this wire is L. Okay. Then I will consider the density called linear charge density. Linear charge density represented by lambda. So linear charge density is given by the total charge divided by length on which it is distributed. What is the total charge in it? Let's consider Q, or you can write it as small q also. Q divided by the total length. Okay, total charge divided by total length will give you linear charge density. Or if you consider a small portion of it, let's consider in this dq amount of charge is there and small length is dl. So then lambda is given by dq by dl, or you can consider it as x, so dq by dx. Okay, this is called linear charge density and its unit is coulomb per meter. Coulomb per meter. So for charge it is coulomb meter. Okay, so using this for linear charge distribution, how to derive an expression for electric field, that is what we are going to learn. Okay, in these three cases are there, we will learn one by one. First one, here we have a straight wire so on which the charges are distributed. Charges are distributed. What is the electric field due to this straight wire along its axis? Here, what is the electric field? Electric field along the axis, which is at a distance, let us consider A, or you can consider it as x also. It is up to you, whatever the distance that you need to take, you can take. You can consider it as r also. And let us consider the length of this wire is capital L. Okay. So what I will do, first I will write the electric field due to a small charge element. Here, how to find out the small length element? Let us consider this is the length element dl, or dx also you can consider. So which is having a charge dq. Okay, which is at a distance how much? X from this point, let me consider this point is P, wherein I need to find out electric field. So now, due to this small current element, what is the charge element, what is the electric field here? We have already studied electric field due to point charge, right? So that is, let me consider electric field due to this small charge element is dE. Are you getting what I am teaching? Due to this small charge element, what is the electric field? That is electric field due to point charge 1 by 4 epsilon naught q by r square. Similar to it, we will write here small electric field is equal to 1 by 4 pi epsilon naught. I will write it as k. Okay, then charge is dq divided by the distance x square, which is similar to this formula, E is equal to 1 over 4 pi epsilon naught q divided by r square, or E is equal to 1 by 4 epsilon naught is k, don't get confused, q by r square. K is there, instead of q I have written small dq, instead of r I have taken x, that's it. Okay, now to find out the total electric field due to this complete length, what I will do, we have to do the integration. If you have not learned, so I will try to make a separate video for differentiation and integration. It is very important. So if you are entering second PUC, okay, you must know 4 basic things. One is what is that, you should know better trigonometry at least to basic level. Second one is the integration, third one is the differentiation, and then we have scalars and vectors. These concepts are very important for physics. So E is equal to dE. So what is dE? dE is this one, k dq by x square. Okay, so we have already studied that lambda is equal to dq, just a minute, dq by dx. What is dq now? Lambda into dx. Let me substitute that here. Integration of k lambda into dx divided by x square. That is equal to integration of k is constant here, right? K lambda is constant, it will come out. K lambda is constant divided by x square into dx. So here x is the variable, x here is a, x is increasing, x value here is a plus l. From here to here a is the length, from here to here l is the length. So initial value is a, final value is l. Therefore here limits are given by a to a plus l for integration, a to a plus l. Okay, a to a plus l. So what is integration of 1 by x square? So E is equal to k lambda integration x power minus 2 a to a plus l into dx. Have you studied this formula in integration? X power n, integration of x power n with respect to x is x power n plus 1 divided by n plus 1. See, if you have not learnt integration yet, please let me know in the comment section. I will try to make one more video on integration, basic integration, so that you can understand these kind of things and all. So here this is the formula x power n plus 1 divided by n plus 1. If you integrate this, you will get k lambda x power n plus 1, minus 2 plus 1 is minus 1 divided by minus 2 plus 1 is minus 1, between the limits a to a plus l. Okay, so this will become k lambda, so then minus is there, minus, so 1 by x a to a plus l. Okay, so E is equal to minus k lambda, upper limit first 1 divided by a plus l, minus lower limit in place of x, correct now? Basic integration, that is equal to k lambda 1 divided by a minus, I will just multiply minus inside, we will get 1 divided by a plus l. So, this is your answer. You can further simplify this like E is equal to K value is 1 by 4 pi epsilon naught. If you cross multiply A plus L into 1 is A plus L minus A. So, A get cancelled, L will be there, lambda L divided by A into A plus L. Like this also you can get. Okay, and lambda is given by charge by unit length, L get cancelled, we get charge. So, this is the electric field due to linear charge distribution, and the point is taken along the axis. It is along the axis. Is that clear? Now, sir, what is electric field in the perpendicular direction? What if I consider point here, 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 here? That comes in the second case. Shall we discuss about it? Yes, sir. Just a minute. Okay, now let's consider this straight wire in this direction vertically, on which charge is distributed. Okay, this is not exactly straight line. Okay, plus 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 plus. Okay, so along this what is the electric field here? Some random point here also, here also, here also. You can anywhere you can consider, not exactly at the center. Also you can consider here. So here what I will do, consider a line whose length is A. I need to find out the electric field here. First I will consider a small charge element. Okay, so from here to here and here to here I will draw some lines. So it is taken at an angle phi. At angle phi I have considered a small charge element on which charge is dq and the length is dl. So L is the length from here to here. L is the length from here to here. Okay, this angle will be how much? D phi, small angle D phi. So electric field due to this charge element will be radially outwards in this direction, that is DE, small electric field. But I want the electric field due to a complete wire. So what I have to do, I will take this side also one angle, that is theta 1, this is theta 1, and this side also consider one angle, this is theta 2, this side it is theta 1, this side it is theta 2. So here you will get two components. If I take, this is the horizontal, so that is perpendicular to the wire. This is phi already, and this will also be phi, vertically opposite. So DE along this direction is DE cos theta. This is along the perpendicular. You can consider DE perpendicular, and parallel to this wire there will be electric field downwards. If you take this small charge element this side, this will come upward. So this is DE parallel, nothing but DE sin theta, that is DE sin theta, or here it is phi, not theta, actually it is phi. So both of them should be considered. First, I'll find out electric field due to small charge element. How much? So that is dE is equal to. So let's consider this is the distance from here to here. Distance to this point P from charge element is R. Electric field is given by K, that is 1 by 4 pi epsilon naught. Q, that is dQ divided by R square. Here K is constant, but dQ is a variable. Charge can be varied, R can be varied. Two variables are there. So I will convert this into one variable by using, since lambda is equal to dQ by dL. What is dQ? Lambda into dL. So I'll substitute here K lambda into dL divided by R square. Again dL is a variable. So what I will do is I will take this right angle triangle. So if you consider a right angle triangle here, here we have phi, here we have L, this side we have A. If you consider this right angle triangle, what is cos phi? Cos phi is equal to adjacent by hypotenuse. Hypotenuse is R, A by R. So what is R? A by cos phi. One more. What is tan phi? Tan phi is equal to opposite by hypotenuse, sorry, opposite by adjacent. So that is L by A, or L is equal to A tan theta, tan phi. Here we have dl, so differentiate this. Dl is equal to A, differentiation of tan phi is secant square phi into d phi. Correct, no? Integration differentiation is very, very, very important. Okay, now I will substitute this one here. So dE is equal to K lambda, dl is A secant square phi into d phi, that is dl value, divided by R value is A square R square, A square by cos square phi. Cos square phi will go up, cos square phi. So sin square phi into cos square phi is 1, because cos phi is equal to 1 by secant phi. Cos phi is equal to 1 by secant phi. They get cancelled. 1a, 1a get cancelled. So now if you check, we have d is equal to K lambda d phi divided by A. That's it. D electric field due to this charge element is given by this one. Now calculate perpendicular and parallel. So first I will calculate perpendicular electric field. Perpendicular electric field. Okay, let me erase this. If you want, you can write it separately. Perpendicular electric field. So E perpendicular is equal to integration of dE perpendicular, that is dE cos phi. So dE is what? Shall I write here? E perpendicular is equal to dE K lambda by A into d phi. Cos phi is there, cos phi d phi. Under the integration. Now E perpendicular is equal to, what are the limits for phi? This side theta 1, phi is varying till theta 1. This side theta 2. Anti-clockwise theta 2, I will take it as minus theta 2. So minus theta 2 to plus theta 1. This is theta 1. So E perpendicular is equal to K lambda by A. Integration of cos phi is sin phi. So integration is done. This is sin phi between the limits minus theta 2 to theta 1. So E perpendicular is equal to k lambda by a. Upper limit is sin phi, upper limit is theta 1 minus lower limit is sin minus theta 2. Sin of minus theta is minus sin theta, so minus into minus will become plus. So E perpendicular is equal to k lambda divided by a into sin theta 1 plus sin theta 2. That's it. So this is for perpendicular electric field. Note it down. So after that we'll discuss about the parallel electric field. You can pause the video and note it down. Okay, now we'll move on to parallel electric field. K lambda d phi by a, you can just remember. dE is given by k lambda divided by a into d phi. So perpendicular electric field is done. Then we have parallel electric field. Okay. So dE parallel, so total E parallel is equal to, integration we have to do. So dE sin phi, dE sin phi. So what is dE? dE is given by k lambda by a, k lambda by a into d phi is there. First I will write sin phi into d phi. Between the limits we have to write the limits. The limits are from minus theta 2 to plus theta 1, again minus theta 2 to plus theta 1. Okay. Next we have E parallel is equal to k is constant, lambda is constant, a is constant. Integration of sin phi is what? d phi. Between the limits minus theta 2 to plus theta 1. So E parallel is equal to k lambda divided by a. Okay. Integration of sin phi is minus cos phi. Between the limits, I will take minus outside. Between the limits minus theta 2 to plus theta 1. So E parallel is equal to minus k lambda by a cos theta 1 minus of cos theta 2 minus theta 2. E parallel is equal to minus k lambda divided by a cos theta 1 minus cos of minus theta 2 is cos theta 2. E parallel is equal to k lambda by a cos theta 2 minus cos theta 1. Okay. So this is about parallel electric field. Okay. One more case is there, that is electric field to curved wire. So we'll discuss about that in the next session. Okay. Yeah. Thank you. I will erase this later.